Class example 3.43. Express each as a single log. So if we're going to express these three terms as a single logarithm, we first need to make sure that we have the same base, which we do, but we also can't have these coefficients sitting out front if we're going to use our log laws to combine these terms. So the very first thing we're going to do is any of the coefficients that are out front, we're going to move those up to the exponents. And then while we're at that, it would be a good idea to change any radicals into exponential form so that we can multiply those and simplify them a little bit more. So our square root of x became x to the power of a half. It's a lot easier to multiply a half by 4. Now we're going to use our exponent rules to simplify. So really in this case it's going to be, if we have a power to a power, then you just multiply those. Now at this point, we're ready to combine into a single logarithm. So we have the same base for all of them, and we just need to take note of the terms that are positive and the terms that are negative, because our positive terms will go in the numerator and our negative terms will go in the denominator. So x to the power of 6 over x to the power of 2 and x to the power of 3. And then we will just simplify inside the argument for the log. So x squared times x to the 3 in the denominator became x to the power of 5. And then x to the power of 6 over x to the power of 5. We just simplified to x. So log base 2 of x. So b looks a little more complicated, but it's actually not going to be much different. We have one extra step here, though, where we are going to want to distribute this negative into both terms in these brackets. And then move our coefficients in each of the terms above into the exponents. And then we can multiply in this case, because we have power to a power for each of them. Careful on this one, we have 1/2 times 4, which would give you 2. Now we're ready to combine, so any positive terms will be in the numerator, negative terms will be in the denominator. And then we'll just simplify where we can. So our x squared times x to the 6 became x to the 8. Y to the 6 over y to the 2. We'll simplify that down to y to the 4 in the next step. Y to the 3 divided by, z to the 3 divided by z to the power of 1 over 3. So we need to subtract those exponents. And we get log base 2 of x to the power of 8, y to the power of 4, z to the power of 8 over 3. Now, we don't really want to leave this as a fractional exponent. We kind of want to go back to whatever form it was in to begin with, right? So we see that there was radicals in the original equation, so our answer should be with radicals as well. So our answer would become log base 2 of x to the 8, y to the 4, and then our z will be the cube root of z to the power of 8. Remembering that the denominator of the fraction is the index and the numerator is the exponent.